For pretty much all of human history, we've thought of gravity as this fundamental, inescapable law, right? It just is. But what if it isn't? What if gravity is less a law we have to obey and more a force that we can actually engineer? Well, we're about to dive into a seriously radical new theory that could, and I mean this literally, turn science fiction into an engineering reality.
And that really is the heart of it all. That's the big question for today. I want you to try and forget everything you think you know for a minute. We're asking if we can build devices that don't just brute force their way against gravity, like a rocket, but can actually manipulate it, shield themselves from it, or maybe even create it whenever we want.
So to even begin to talk about controlling gravity, we have to first completely rethink what it is. And that means we've got to make a fundamental shift away from the standard model we've been using for over a century.
Okay, let's break this down. On the left, you've got the standard view from Einstein. Mass tells spacetime how to curve, and that curve tells other things how to move. It's all about geometry. But this new hypothesis on the right, it's something else entirely. It says that space isn't just empty geometry, it's a physical medium. Mass doesn't bend space, it changes the properties of that medium, kind of like how dropping a bowling ball into a swimming pool changes the pressure all around it. We're shifting from thinking about pure geometry to thinking about, well, material science.
And this is where things get really wild. This whole idea hinges on one concept. The vacuum of space isn't empty. It's not a void. It's a real, tangible, physical medium that we can potentially push on, stress, and manipulate, just like we do with air or water.
So this leads us to the concept of a capacitive vacuum. Now, I know that sounds super technical, but stick with me. Think about an electronic capacitor, right? It just stores energy. This theory says the entire universe works kind of like that. Stars and planets are like the charged plates, and the space in between is the insulator, the dielectric. So in this model, gravity isn't some spooky force, it's just the energy, the stress that's being stored in the very fabric of space itself. And check this out. This shows you just how different the results are. In the standard view, an orbit is basically a constant state of falling. But in this capacitive view, it's more like floating, just staying on lines of equal potential. Or think about this. In the standard model, a star can't really capture a rogue planet unless a third body gets involved to slow it down. But if space is a medium, well, that planet feels drag. It loses energy, and it falls into orbit all on its own. And here's the big one. Standard gravity can't repel. But a potential barrier? Oh yeah, that can definitely repel.
So if this new view is right, if gravity really is just a property of a medium, then it suddenly stops being a law of physics and starts being an engineering problem. And like any good engineering problem, there are a couple of different ways you could try to solve it. This is where we get to the really cool stuff, propulsion and shielding.
So this gives us a fundamental choice, a real fork in the road for engineering. Do we try to overpower gravity with a drive system, basically creating our own stronger gravity well to fall into, or do we get a little more clever and build a shield that just makes us invisible to the gravity that's already there? Brute force versus an elegant solution.
And this analogy just makes it all click. A drive is like trying to swim up a raging river. You have to generate a force that's way stronger than the current pushing against you. It's all effort. But a shield is like greasing the hull of your boat. You're not fighting the river at all. You're just making it so the water slips past you effortlessly. You're decoupling. It's a much smarter and probably a much lower energy way to do it.
All right, so let's run with that elegant solution. How in the world would you actually engineer a gravity shield? We're about to go from the what if to the how to. And believe me, the concepts are just fascinating.
The main goal isn't to push against gravity, it's to break the connection, this sort of phase lock that holds an object to the Earth's gravitational potential. Imagine you have two tuning forks that are perfectly in tune. If you strike one, the other starts to vibrate too, right? That's sympathetic harmony. Our goal is to introduce a bunch of noise so that our tuning fork just stops listening to the Earth's.
And the engineering term for this is phase conjugation. Basically, you create a local, rotating electromagnetic field around your craft. This field acts like a signal scrambler. It creates dissonance. It just totally messes up that sympathetic harmony. The Earth's potential can no longer get a grip on the craft, and so it just becomes buoyant, kind of like a bubble of air rising up through water. You've effectively just unplugged yourself from gravity.
But the shape, the geometry of that field has to be perfect. Just spinning a ring like a frisbee, that's called toroidal rotation, it's not going to cut it. You'd still leave the top and the bottom poles of your craft exposed. You also need what's called poloidal rotation, where the material inside the ring is also rolling inside out, just like a smoke ring does. That combination is what creates a completely closed, hermetically sealed bubble, totally isolated from the outside gravitational field.
Okay, I know what you're thinking. This all sounds incredibly theoretical, right? Pure science fiction. But are there any real-world hints that any of this might actually be possible? Well, let's look at some very tantalizing and, I should say, highly controversial clues from the lab.
So, back in 1992, a physicist named Eugene Podkletnov claimed he'd done something amazing. By spinning a superconducting disk really, really fast, he reported a small but totally measurable reduction in the weight of objects he placed above it. Now, the key here is he wasn't just spinning a chunk of metal. He was spinning a quantum condensate, a special state of matter that acts like one single coherent wave. And in theory, that's what allowed him to rotate the local gravitational potential field itself.
Now, his results are definitely controversial, but they're not totally out in left field with no theoretical basis. It actually lines up pretty well with a concept called the Woodward effect, or the Mach effect. This theory, which NASA has actually funded research into, suggests that you can cause tiny temporary fluctuations in an object's mass just by pulsing energy through it. It's like creating a tiny mass wobble that you can then push against to get propulsion, all without shooting anything out the back.
But here it is. This is the most counterintuitive and honestly the most compelling piece of evidence for me. In some of these experiments, when the device is turned on, it gets cold. Now that should not happen. It completely flies in the face of standard thermodynamics, which says if you're pumping a bunch of energy into a system, it should get hot, not cold.
This bizarre cooling effect suggests the device is acting as an entropy pump. Okay, here's the logic. To create a highly ordered state, like a perfect gravity shield, the device has to get rid of disorder from its immediate surroundings. And what is disorder at the molecular level? It's just heat. So the device is literally absorbing random heat energy from the air around it and converting it into useful gravitational work. It's a refrigerator that uses the cooling process to power itself. So that chilling effect, it's not a weird side effect. It's the proof that it's working.
The idea of a gravitational refrigerator is just incredible, but let's bring it back down to Earth for a second. The path from these tiny, strange lab effects to an actual flying machine is paved with some absolutely immense engineering challenges.
And these hurdles are no joke. We're talking about needing materials that can handle forces we can't even properly generate yet. We'd need power sources with an unbelievable energy density. And there's this huge danger called dielectric breakdown. Basically, if you push the device too hard before it starts to lift, you don't fly. Your machine just turns into a giant ball of lightning. And on top of all that, the effect itself seems to be fundamentally very weak, which means it takes a colossal amount of energy to get even a tiny little result. But even with all those challenges, you have to admit the shift in perspective is just profound. It completely reframes our place in the universe. It suggests that gravity might not be this fundamental law that we have to obey forever, but just another force of nature that's waiting for us to understand it and then to harness it. And that really leaves us with one last thought. If we can solve the gravity problem, what other laws of physics are just waiting to be broken?